Cracked one open this morning, or yesterday, or maybe you've got one sitting on your desk right now. That familiar green M on a black can, the hiss when you pull the tab, that first sip that hits different from anything else in the vending machine. But here's the question almost nobody asks. What actually goes into making that can? Not the ingredient list on the back, you've seen that. The real question is how a factory takes caffeine powder, synthetic amino acids, and 54 grams of sugar and turns it into 11.5 billion cans a year. That's right. Monster ships 9 fiery 8 million cases annually. Every single one of those cans passes through a production line running at 130,000 cans per hour, and the entire process from raw ingredient to sealed pallet takes just 45 minutes. This is the complete story of how Monster Energy is made, from the water treatment plant to the can in your hand, and the details are wilder than you think. Step 1. Ingredient release and formula staging. Every Monster production run starts the same way. A certificate of analysis for every single ingredient. Caffeine, taurine, B vitamins, sucralose, glucose, proprietary flavor bases that arrive in sealed drums from facilities nobody outside the company can identify. Each one gets lot-coded, allergen traced, and checked against a master formula sheet before it even enters the building. If a caffeine shipment is off-spec, too much or too little by even a fraction, the entire batch gets rejected. The reason is simple. Monster operates under FDA 21 CFR 117 preventive controls, and a single caffeine deviation could trigger a legal label violation across multiple countries. The caffeine itself is pharmaceutical-grade. Most of it is synthetic, manufactured in controlled chemical plants to guarantee consistency, batch after batch. Natural caffeine from coffee or tea varies by crop, region, and season. Synthetic caffeine doesn't. And in a product shipping to over 140 countries, consistency is not optional. From here, everything gets staged for the batching tanks. Powder reductors pull the dry ingredients into solution. Mass flow meters measure every gram. The Crohn's ContiFlow mixer, the heart of the modern beverage line, is configured for 15 to 90 cubic meters of syrup throughput per hour. Step 2. Water treatment and deaeration. The single biggest ingredient in your Monster can is water, but not tap water. Not even filtered tap water. The water used in Monster production goes through multi-stage filtration, reverse osmosis, and UV sterilization before it ever touches a single ingredient. Then comes a step most people never think about: deaeration. Dissolved oxygen is the enemy of carbonation. If there's too much O2 dissolved in the water, the CO2 won't absorb properly, and the drink goes flat before it reaches the store shelf. So the water passes through a ContiFlow vacuum stage operating at less than 50 millibars of pressure, chilled to 2 to 4 degrees Celsius. The residual oxygen drops below 0.5 milligrams per liter. That's low enough that when carbonation hits later, every bubble locks in place. Step 3. Syrup batching and sweetener dissolution. In separate staging tanks, granulated sugar or liquid high fructose corn syrup is dissolved at 35 to 40 degrees Celsius, then cooled. The target sweetness is measured in Brix, a scale that tracks sugar concentration by density. The inline densitometer monitors Brix 2 within plus or minus 0.05 degrees. That's not a guess. That's industrial precision. If the Brix drifts even slightly, the entire line knows within seconds. This is also where the active ingredients get added. Caffeine, taurine, an amino acid that supports neurological function and muscle performance, synthetically produced for purity. B6 and B12 vitamins in liquid form and measured to the microgram. Too much B12 alters the taste and creates an unpleasant aftertaste. Too little and the label claim doesn't match reality. Either way, it's a regulatory problem. Now, step 4. Final blending and high-pressure carbonation. The syrup base and treated water blend at a 1:4 ratio, the standard carbonated soft drink proportion. Then the carbonation hits. CO2 is forced into the liquid at 8 bar of pressure. Now that's roughly 4 times the pressure inside a car tire. The Crohn's ContiFlow guarantees plus or minus 0.05 volume CO2 accuracy. The entire blend must stay at 2 to 3 degrees Celsius during this step. Any warmer, and Henry's Law kicks in. The gas blows off immediately, and you've just made flat syrup. If you're still watching, you're the kind of person who actually wants to know how things work. And that's exactly who this channel is built for. Hit subscribe, because what comes next is the part where things get really fast. Step 5. Counterpressure filling. This is where the line goes berserk. The Sidel EvoFill can system runs at over 130,000 cans per hour. That's 36 cans every single second. Each can is pre-purged with CO2 to displace air, filled at approximately 2.5 bar of counterpressure, and seamed within half a second of the fill valve closing. The fill level standard deviation is 1 milliliter. 1. Every can, every time. An inline X-ray fill level camera watches every single unit pass by, and any can that's even slightly over or under gets kicked off the line at full speed. The aluminum cans themselves arrive pre-printed with that iconic green claw mark on black. Monster doesn't paint or label cans after filling. The decoration is applied at the can manufacturer before the cans ever reach the bottling facility. This means the inside of the can is food-grade epoxy coated to prevent the drink from reacting with the aluminum. And that coating is applied at the same factory that forms the can from a single aluminum disc through a process called drawing and wall ironing. Easy roll. Step 6. Double seaming and thermal stabilization. Within half a second of filling, the lid drops and the double seam operation locks it in place. A double seam is not a crimp. It's a precisely engineered mechanical interlock where the can body curl and the lid curl fold into each other twice under controlled pressure. The critical metrics are seam thickness, countersink depth, and overlap. Every 30 minutes, an external seam inspection runs. Every 4 hours, a full teardown inspection, literally cutting the seam apart and measuring it under a microscope. A bad seam means CO2 leaks, contamination enters, and the product fails on a store shelf thousands of miles away. Where pasteurization is used, and this varies by product and region, the sealed cans pass through a tunnel pasteurizer. The profile: 80 degrees Celsius for 8 to 10 minutes at 13.5 bar, delivering approximately 25 pasteurization units. This kills any surviving microorganisms without destroying the vitamins or altering the flavor profile. Memory. Step 7. Inspection, coating, and packaging. After seaming and stabilization, the cans run through a Krohn's CheckMat Compact, a high-speed inspection system that checks for out-of-tolerance seams, incorrect fill heights, missing date codes, and any cosmetic defects. All at line speed. No slowdown. Cans that fail get rejected automatically. Then comes secondary packaging, automated tray packers, palletizers, and stretch wrappers. A single pallet holds thousands of cans, each one identical to the last. From raw ingredient to wrapped pallet, the total elapsed time on a 90 cubic meter per hour line is approximately 45 minutes. The modern Monster co-packer facility runs at roughly 85% automation. The only manual step left? A sensory release tasting. A human being opens a can and confirms it tastes like Monster. Now, the most shocking thing that the ingredient label doesn't tell you. A single 16-ounce can of Monster Original contains 54 grams of sugar. That's 13.5 teaspoons. In the time it takes you to finish the can, maybe 10 minutes, you've consumed more sugar than the American Heart Association recommends for an entire day. The caffeine content is 160 milligrams. That's less than a venti Starbucks coffee, but it hits faster because it's dissolved in a liquid with carbonation that accelerates absorption through the stomach lining. Then there's the taurine question. Reddit threads with thousands of upvotes debate whether taurine is dangerous. It's not at normal doses. Taurine is naturally present in meat, fish, and human breast milk. The synthetic version used in Monster is chemically identical. But here's the catch. The EU requires any energy drink with caffeine above 150 milligrams per liter to carry a warning label. Health Canada caps energy drink servings at 180 milligrams of caffeine. Australia and New Zealand enforce a 145 to 320 milligram per liter range under FSANZ standard 2.6.4. Monster Original at 160 milligrams per 16 ounce can sits just under every major regulatory ceiling, by design. And the market behind all of this? The global energy drink market hit $83 billion in 2026. It's projected to reach $157 billion by 2034. Monster alone shipped 11.5 billion cans last year. Coca-Cola owns a 20.9% stake in the company as of February 2026. This is not a niche product. This is an industrial machine that runs 100 to 30,000 cans an hour, every hour across multiple continents to feed a market growing at 8% a year. Me. So the next time you hear that hiss when you crack open a black and green can, you know what's behind it. Water filtered through reverse osmosis and vacuum-deaerated to 0.5 milligram of oxygen per liter. Sugar measured to within 0.05 Brix. Caffeine dosed to the microgram from pharmaceutical-grade synthetic sources. 130,000 cans filled every hour at 2.5 bar of counter pressure. Seams inspected every 30 minutes and torn down every 4. A machine that turns raw powder and water into 11.5 billion cans a year in 45 minutes flat. It's not just a drink. It's the most precisely engineered can of sugar water on the planet. Do follow and subscribe. We have a bunch of videos lined up. The manufacturing process behind the world's most extreme machines.